This is the fluid pressure and flow simulation. One can find this simulation on phet.com. In this simulation, we will see Bernoulli's principle in effect and also observe how pressure and height affects the speed of the fluid as it flows. Here, I have already set up a water tower with a speedometer and a pressure sensor. Please take a moment to establish this setup on your own. You may want to take notice that as the water spills, the pressure goes down. As the pressure goes down, so does the speed of the fluid. This is the first relationship that Bernoulli's principle shows. Another setup will relate height to the speed of the fluid, which I will show you in just a moment. Okay, here's our next setup. We're using the same water tower, but this time we have a hose attached to it that can be moved up and down to simulate different heights. Two speedometers are placed at different heights where the water will spill out of the hose. I've set the faucet to match the leakage so that I don't have to worry about filling the tower back up every once in a while. I will now pause for a second to allow you to replicate the simulation I have on my screen on yours. As I begin to release the water with the hose closer to the height of the water tower, the speed reads 16 meters per second. Then, as we bring the hose down to a larger difference in height, we see that the speed becomes greater as we go further down. In our instance, it is now 20.4 meters a second, a large increase in speed. From this observation, we can all agree that a larger difference in height creates a larger difference in the speeds of the fluid. In other words, different heights will produce different speeds. In summary, this simulation shows the properties of Bernoulli's principle and how height affects the speed of a fluid. For more information regarding Bernoulli's principle, feel free to reference our other videos in this series.